Hello everyone, welcome to another video of mine, and in this video we will be solving question number 9 of May-June 2005 paper 3. So get your calculators ready and we're going to get going. So this question is particularly related to differentiation and integration, to the topics of differentiation and integration. So yes, let's get started. So let's read the question first. The diagram shows part of the curve y is equal to x over x square plus 1 and its maximum point M. The shaded region R is bounded by the curve and by the lines y is equal to 0 and x is equal to p. Calculate the x coordinate of M, and the marks are 4. We have to calculate the x coordinate of M. And what do we know about M? That it's the maximum point, and at the maximum point what do we know? We know that dy over dx is equal to 0 at the maximum point, because the first derivative tells us the slope at a particular point, and at the maximum point the slope is a straight line and the gradient of a straight line is 0, hence for the first derivative is 0. So calculate the x coordinate of M. So first of all, what we are going to do is I'm going to write over here dy over dx is equal to, now we are going to be using the quotient rule over here. So you know that this is u and this is v. So we write v as it is, so we are going to writing x square plus 1, and then we are going to take the first derivative of u, and the first derivative of u x is 1. Then there's going to be a subtraction sign in between. Then again we are going to write u x and the first derivative of v, and the first derivative of v is x. Now v is x square plus 1, and the first derivative of x square plus 1 will be 2x. The derivative of x square is 2x, and of a constant number is 0. So this is what we're going to get, and then in the denominator we're going to get v square. So x square plus 1 whole square. So just write it like x square plus 1. Both of them are going to get multiplied by 1 and are going to give the same, minus 2x square. X square plus 1 whole square. Now please don't expand this yet, because you're going to see why expanding this is just going to be a redundant and extra step, because at max we know, at maximum point we know dy over dx is equal to 0. dy over dx is equal to 0. So dy over dx is going to become 0. So 0 is equal to x square plus 1 minus 2x square. This is just going to be, and then we have x square plus 1 whole square. We know that x square minus 2x square is going to give us minus x square plus 1, and we are just going to take it, we are going to multiply this over here, and what we are going to get, we're going to get 0 is equal to 0. Just bring minus x square over here, we are going to be left with x square is equal to 1. Taking square root, so this is just going to be x is equal to plus or minus 1, and minus 1 is going to get rejected, so minus 1 rejected, and x is equal to 1 is your answer. Why is minus 1 rejected? Because minus 1 is on the left hand side of the graph. Minus 1 is going to be somewhat over here, but we are on the right hand side of the graph, so x is equal to 1 is the correct answer. So now we are going to be moving to the second part. Find the area of R in terms of P. Now we have to find the area of R in terms of P. So we know that one line, that the curve is bounded by this line and this line, and we don't know the value of P yet, and even the question asks that the area of R should be in terms of P. We have 0 and we have P, and this is a area that we have to find. So what we're going to do is, we know that the integration gives us the area. So find the area of R in terms of P. So area is equal to x over x square plus 1 dx. We have 0 over here and P, because the curve is bounded by these two limits, 0 and P. So now what we're going to do is, now you should know this from before, way before, that what is this, x over x square plus 1. Now we know that in integration, if we have, now sorry, my bad, let me remove this. We know that in integration, if we have f dash x over fx dx. Now over in the if we have the first derivative of the denominator in the numerator, so its integral becomes ln fx plus c. It's the absolute value of the denominator, simply that. The more you're going to practice, the more easily you're going to identify this. That's why it's called the recognition method. So as we can see over here, x square plus 1, what is the first derivative of x square plus 1? It's 2x plus 1, but we don't have 2 in the numerator above. So what we're going to do, we're going to multiply and divide by 2. Multiply and divide by 2. So we have area is equal to 0 over P, and then we're going to be with 1 over 2 into 2x x square plus 1 dx. And as we know that 1 over 2 is constant, so we can take it out of the integral. So this is going to be 1 over 2 0p 2x x square plus 1. But hey, now see what has become. Now the first derivative of the denominator is in the numerator, so we can simply do this ln denominator fx plus c, but we won't be needing c over here because we have the limits, we have the boundaries, is equal to 1 over 2 ln. Please do tell me in the comment section if you understood this part or not, so I can briefly make another video if you aren't able to understand this. So 1 over 2 ln x square plus 1 0 p 0 p. So now we are going to be simply adding the limits. Sorry, let me remove this, and let me do this. So applying limits, so this is simply going to be 1 over 2 ln p square plus 1 minus 1 over 2 ln 0 plus 1. Over here we know that ln 1 is 0, we already know that, so this is going to become 0, and we're going to be left with 1 over 2 ln p square plus 1, and that is our answer in terms of p. So we just had to did the c, easy peasy. So the only the kick or the main thing in this question was that you have to recognize this, because otherwise you can't solve the integral. If you're going to do this, you have easily done the question, you're done with the question. So now we are going to be doing with it, now we are going to be solving the third part. Hence calculate the value of p for which the area of R is 1, giving your answer correct to 3 significant figures. So get your calculators ready and we're going to get going. So from part 2, remember, whenever the word hence is used, it means the above part is being used. If you can't solve the above parts, unfortunately you won't be able to continue forward. So hence means the answer from the above or from the before part. So we know that from part 2, from part 2 we know that area is equal to 1 over 2 ln p square plus 1. So we know that the area given in the question, area is 1, area is equal to 1, is equal to 1. So we're going to substitute area is equal to 1 over 2 ln p square plus 1. So this is just going to get multiplied over here. So we're going to be left with 2 is equal to ln p square plus 1. So taking base on both sides, I've also explained in another video of mine what's actually happening over here, taking base on both sides, on both sides. So e square is equal to e ln p square plus 1. We know that e ln a is equal to a. So we are just going to get p square plus 1 over here. So e square is equal to p square plus 1. This thing is being used over here. E ln a is equal to a, and then we're going to get this. E ln a over here, the a is p square plus 1, and we simply got p square plus 1. So we're going to separate them. P square is equal to e square minus 1. Taking square roots on both sides. Taking square root. Taking square root. So what are we going to get? We're going to get p is equal to plus or minus e square minus 1. So pick up the calculator and tell me what is the answer you're going to get. E square minus 1, it's 2.527. So p is equal to 2.527, or p is minus 2.527, which is going to be, this is going to be rejected. But as the answer says, giving your answer to correct to three significant figures, this is going to become p is equal to 2.53, because the 27 is much closer to 3. So we are just going to write it to three significant figures, 2.53. So this is one significant figure, two significant figure, three significant figure. Over here we have four significant figures. So yes, we are done with the May June 2005 question number 9. I hope so you understood the question, and hope so this is going to help you in your preparation as well. See you in another video. Take care. Bye bye.